Hello and welcome back. This is the lecture slideshow for weeks 14 and 15 of the Philosophy of Science course. This will be the last lecture for this course. It focuses on Module 7, Philosophical Problems in Physics, Biology, and Psychology. For this, read Okasha Chapter 6, my handout 7 in Canvas. Read also now the entire Dennett and Plantinga text. In these weeks, I'll discuss naturalism versus supernaturalism, or how do scientific and religious worldviews conflict. Explore also the links to additional content within Canvas Module 7, especially the 4 videos I have listed here for you. We'll begin with these questions. What makes a theory scientific and what makes a scientific theory good? See handout 7, it has lots of examples. Here are 6 virtues or strengths of good scientific theories. None of these criteria are necessary, and altogether these are insufficient. But the more a theory satisfies these, the better it is. Plausibility, that's when a theory is more acceptable if it makes clear, accurate, credible assertions about specific phenomena, consistent with observations. There always need to be observations. Conservativeness, this is not the political idea at all. This is the notion that a theory needs to be compatible with other well-established, generally accepted scientific beliefs about the world. Testability. We've talked a lot about this. I'll say a bit more. This is when a theory must feature precise, informative descriptions, predictions, and explanations about what should and should not be observed. Explanatory power. This is where the best theories explain a variety of similar cases or related phenomena better than rival theories. Fertility. A theory ought to be fruitful by opening up new areas of research, asking further questions, and solving even more problems than it was originally invoked to explain. Simplicity. A theory should rely upon as few unsupported or controversial assumptions as possible. Postulated entities should not be multiplied beyond what is required for description or explanation. Let's review testability. Recall that every scientific hypothesis has to be incompatible with some observations. Each must imply something true and something false, so that we can rule out competitors. Alfred Ayer offered the notion of verifiability, which is the idea that scientific claims are empirically verifiable in that their truth can be established through controlled observations. Karl Popper offered the idea that scientific claims are empirically falsifiable, that is, their truth should be incompatible with some observations. We can use both criteria. Any scientific theory needs claims, hypotheses, that can be confirmed or disconfirmed by experiments. I want to talk to you about something I've mentioned only briefly before. It's called inference to the best explanation. It's this. Given evidence E and candidate explanations H1 through Hn of your evidence, if, say, Hi explains your evidence better than any of the other hypotheses, we infer that Hi is closer to the truth than any of the other hypotheses. For instance, how do we explain wet grass? If the grass is wet, it probably rained, we think. Rain is the best explanation for wet grass in winter, but not in summer. Where sprinklers are in use, rain is not the best explanation for wet grass, especially here in the Central Valley of California, especially when the grass is wet but the street is dry. Inference to the best explanation is choosing the hypothesis that best explains all available data. Here's Gilbert Harman on this. In making this inference, one infers from the fact that a certain hypothesis would explain the evidence to the truth of that hypothesis. In general, there will be several hypotheses which might explain the evidence, so one must be able to reject all such alternative hypotheses before one is warranted in making the inference. Thus, one infers non-deductively from the premise that a given hypothesis would provide a better explanation for the evidence than would any other hypothesis, to the conclusion that the given hypothesis is true. The inference to the best explanation is also called abduction. Same thing. When a theory satisfies most of the desired criteria for being good science, it must then be tested against its rivals. Otherwise, we have no good reason to prefer it over any other. Choose one theory over another by examining their rival testable hypotheses and implications, then tentatively accept the best explanation available. We can make the choice using abductive reasoning or inferring that the best available explanation is probably true. See handout 6 and chapter 2 in the Akasha text for more on this. So how do we choose which theory to accept? Well, we make observations and consider alternative hypotheses, say H1 and H2. We should infer H1 rather than H2 if and only if H1 is a better explanation of observations than H2. We examine each theory's component hypotheses, the testable assumptions and predictions. We must produce a test which conclusively rules one hypothesis out. True prediction is not enough evidence for any one hypothesis over its rivals. In principle, this test has two essential parts requiring a crucial observation. Here's how it works. I call this applying the surprise principle to rival hypotheses. An observation O strongly favors hypothesis 1 over hypothesis 2 when the following two conditions are satisfied, but not otherwise. 1. If H1 were true, you would expect your predicted observation to be true. And if H2 were true, the rival to H1, if H2 were true, you would expect your observation not to be true. So you want to find an observation that distinguishes the two hypotheses. That is, if H1 were true, then your observation would be unsurprising, and if H2 were true, that same observation would be surprising. You want to produce a test which definitely rules one hypothesis out. Let's see how this works. What is happening in this image? Looks like a heart attack. Man is clutching his chest. Here is how we infer that a theoretical hypothesis is more plausible than its rival using a prediction over which both disagree. Here's an example from an emergency room case. A 50-something-year-old male who has recently eaten a big meal feels a massive aching pain in his chest. So he goes to the hospital. He is short of breath and feels sick to his stomach. He suddenly breaks into a sweat and has cold, clammy skin. He complains of dizziness and passes out. Hypothesis 1, well, the patient is having a heart attack. Hypothesis 2, the patient is not having a heart attack. It's something else. And H2, of course, can branch off into all sorts of things. What else could it be? It could be indigestion. Could be a tumor. Could be an allergic reaction to food or drugs. But let's focus on H1 versus H2. H1 being the patient is having a heart attack. H2, patient is not having a heart attack. A heart attack happens when blood flow to a part of the heart is blocked for a long enough time that part of the heart muscle is damaged or dies. The hyperacute phase begins immediately after a heart attack, and you can see this on something called an electrocardiogram. That is an EKG or an ECG. True prediction provides support, but not conclusive evidence for one hypothesis over another, only when what you observe is not what you would expect, were that hypothesis false. Recall, the surprise principle applied. If H1 were true, we would expect to observe an erratic EKG when they connect the person up to a machine which shows the electrical rhythm of the heart. And if H2 were true, we would expect to observe a non-erratic EKG, a normal EKG. So our prediction is we're going to see an erratic EKG if the person is having a heart attack. If we do not see an erratic EKG, that is going to be a reason to rule out hypothesis 1 and favor hypothesis 2. Of course, you'd have to continue. Hypothesis 2 just says it's not a heart attack. You'd have to continue and branch that off into other possible explanations. Rival theories must predict what you will observe when one is true and the other is false. Here's the reasoning. H1 versus H2. H1 is the patient is having a heart attack, H2 the patient is not. Here's the logical argument. Either the patient is having a heart attack or they are not. If they are having a heart attack, then we predict an erratic EKG. If they're not having a heart attack, then we predict a non-erratic or normal EKG. So we actually observe an erratic EKG, which means hypothesis 2 is ruled out because it predicts a normal EKG. And so we accept tentatively H1, namely, the patient is having a heart attack. The inference to the best explanation, or abduction, is useful when trying to decide which theories to choose, at least tentatively. However, there are at least 3 problems. Following this method of inference, strong evidence does not so much support any hypothesis as much as it tells against its rivals. In the case of the patient having a heart attack as opposed to not having a heart attack, we were able to rule out that the patient was not having a heart attack because we did not see a normal EKG. In fact, we saw an erratic EKG. The inference to the best explanation, or abduction, has at least 3 problems or limitations. Using this method of inference, strong evidence does not so much support any hypothesis as much as it tells against its rivals. So with this method, we were able to rule out the hypothesis that the person was not having a heart attack because we saw an erratic EKG. Second, inference to the best explanation only dictates that we choose the better of rival hypotheses. It doesn't make the best hypothesis true or more likely true. Even if this method of inference is useful, we need more than that. And third, we must already assume that one of a range of rival hypotheses is true before the rule can be applied. But it's possible that none of the candidate hypotheses might be true, since the true hypothesis might not be among the alternatives. That is, we may not have the correct hypothesis, we just have the best hypothesis, the one which passes the tests so far. Testability and explanatory power are strengths of good scientific theories, which together enable us to accept better theories over lesser ones. Let's say more about explanatory power. Explanatory power is that feature of the best theories where they explain a variety of similar cases or related phenomena better than rivals. And here we begin considering issues raised in the debate between Alvin Plantinga and Dan Dennett on whether science and religion are compatible. It turns out, in biology, rival scientific theories explain much. Each has great explanatory power: evolutionary theory and intelligent design theory. You should be familiar with these theories by now. Earlier in the course, I had a self-study dedicated to your using the UC Berkeley tutorial and looking at some Wikipedia pages to familiarize yourself enough so that you can understand this debate. So let's contrast at the outset, to get us started, intelligent design theory and evolutionary theory. In general, intelligent design theory, the origin, development, and extreme complexity of life on Earth cannot be explained solely on the basis of chemical or biological evolution, and instead appears to be guided or created by a supreme intelligence. Evolutionary theory. The origin, development, and extreme complexity of life on Earth can be explained solely on the basis of chemical or biological evolution. Now, this is the idea that a supreme intelligence or guidance by an intelligent designer is not required. So you see, these theories are actual rivals. One says God is required, some creator or other with an intellect and a plan is required, ID theory, and the other says not necessarily, possibly not. Again, we're focusing on explanatory power. Let me give you some examples of explanatory power in a theory where there isn't any testability. Hebrew Scripture has a narrative outlined in the first 2 chapters of Genesis which explains creation. It's accepted by the Abrahamic religions such as Judaism, Christianity, and Islam. Any other creation origin story based on hearsay and ancient scribblings explains everything as well. For example, those accepted by Aboriginal Asians and Eurasians, Babylonians, Mesopotamians, Egyptians, Native Americans, Greeks, Romans, Vikings, Hindus, Zoroastrians, Pacific Islanders, Scientologists, etc. Why do I say these origin stories are untestable in the scientific sense? I say this because nothing can disconfirm or refute them. Seriously, what can prove that any of these ancient stories, these traditional origin myths, is false? Such stories, now considered as theories, can account for any observation. Everything is consistent with them. And so they explain everything or nothing. Every observation confirms that mysterious forces and beings made the cosmos. That's how it looks. Now, here are some examples of explanatory power with testability, and I developed these examples further in handout 7, so look there for details. Newton's 1687 universal law of gravitation theory explains the orbits of planets, high tides and low tides on Earth consistent with the lunar cycle, the fall of every unsupported object toward the center of the Earth, and the predictable trajectories of comets, meteors, baseballs, and missiles. Plate tectonics. Perhaps you've heard of this. It's called Pangea theory. This explains the spreading of the seafloor and the oceans, the drifting of continents, geographic distributions of plants and animals, and volcanic as well as seismic activity. This was framed first about 1915. And natural selection theory. I'll spend more time on this. Natural selection is one mechanism of evolution. The theory explains the origins of species and the diversity of species. It explains drug resistance in bacteria, pesticide resistance in insects, malaria resistance in sickle cell heterozygotes. In this, I'm referring here to Darwin's theory in 1859. Plantinga and Dennett debate its implications. I should be clear, Plantinga and Dennett both accept natural selection as a mechanism of evolution. What they disagree about is how compatible it is with traditional religious worldviews. Each of these theories features precise descriptions, predictions, and explanations subject to refutation. For instance, rabbits with feathers could disprove evolution. There are animals with a mixture of mammalian and reptilian features, such as echidnas. And there are fossils with a mixture of bird and reptilian features, such as the toothy Archaeopteryx. However, no animals have a mixture of mammalian and bird features. Finding rabbit fossils in the Jurassic period would falsify the theory. The big problem with a plausible, conservative, powerful, fertile, and simple explanation, though, is that it convinces lots of people. But it isn't disconfirmable. It could be false, and we couldn't tell. For instance, I talked about the case of the convincing explanation of the alleged loss of 21 grams when we die. This is certainly a plausible explanation, but is it even true that we lose the 21 grams? Nope. Here's another story. 2,000 years ago, a young, unmarried Hebrew woman from Galilee, believed not to have been sexually active, becomes pregnant. What plausible theories might explain this phenomenon? Are any of these scientific? So you always have to ask, what evidence could show that my theory is false? And then look for it. Every scientific hypothesis has to be incompatible with some observations. Each must imply something true and something false. You always have to look for what would make it false. It's easy to find confirmations if you look. We are imaginative, creative. We can test it then against observation and rival hypotheses. It's not enough that a hypothesis explains observations. It must imply testable predictions subject to disproof. Only theories whose hypotheses run the risk of refutation can be good scientific theories. Up next, how are science and religion incompatible? Everyone tells us that they're compatible. And sure, some science in some religion is compatible. But I'm interested in mainstream religion, the religion of most people, the worldview of most religious people, and mainstream science. And for this, you should have read by now Science and Religion, Are They Compatible? By Alvin Plantinga and Dan Dennett. Alvin Plantinga thinks in general that science and religion are compatible, and Dan Dennett begins by agreeing with Plantinga, but then on closer inspection we can see that he does not think that they're compatible and that there are serious problems. Here's Alvin Plantinga in a nutshell. Contemporary evolutionary theory is a good scientific theory, but I reject unguided evolution. ID has more explanatory power than ET alone. So science, evolutionary theory, and religion, theism, they're compatible. Evolutionary theory does not rule out God. It can't rule out God. It's possible that God guides natural selection. Now here's Dennett. ID theory has less explanatory power than evolutionary theory, since evolutionary theory predicts serious design flaws, and I'll talk about these observations shortly. ID does not predict these. And if we're testing theories one against the other, each theory should make a prediction, which is true, and make a prediction of what we definitely will not see, so that if we see the thing we shouldn't see, we should give up that theory. Also, Dennett thinks that ID theory needs to grow testables. Evolution without the guidance of mythological beings explains organic complexity, yes, adequately, quite well actually, and shows that no gods are necessary. So science, evolutionary theory, and religion, theistic evolution, are incompatible. Consider the origin story from Hebrew scripture we get in Genesis chapter 1. And what we have to ask ourselves is whether sacred writings are consistent with modern science. Here's an excerpt. In the beginning, God created the heavens and the earth. Now, the earth was formless and empty. Darkness was over the surface of the deep, and the Spirit of God was hovering over the waters. And God said, "Let there be light," and there was light. God saw that the light was good, and he separated the light from the darkness. God called the light day, and the darkness he called night. And there was evening, and there was morning. That's the first day. Here I'm using the New International Version translation. You should feel free to look up other translations. Using Bible Gateway, that's a nice website. Now, how do we know which creation myth to accept? That's just one, and it's used by the major dominant religions of today. But there are other origin stories. Let's stay focused on the Genesis story. This is sometimes called the six-day creation story, where in 6 days God created the world and everything. Is the story literally true or not? Is it, say, metaphorically true? The thing is, literally or metaphorically, it conflicts with physics and biology on the details, on the chronology. And this weakens its accuracy if it's wrong here, if Scripture, the Bible, revered writings, is wrong here, and we've been told these writings are infallible, that they are God-inspired, that they're never wrong, then we've got a problem. Accuracy is questionable. For instance, on day 1, God creates light before creating the sun. Hold on, light comes from the sun, although the sun was not yet created until day 4. Now, the plants were created on day 3 before the sun. Now, you don't get green plants, you don't get plants, photosynthesizing plants, without the sun. At least that's what modern biology says. The sun is the source of light for plants. Further, inconsistent creation stories are told. In Genesis chapter 1, there's one creation story, and in chapter 2, there's another. In chapter 1, it says the first man and woman were made at the same time and after the animals. But in Genesis chapter 2, there's a different order of creation. First you get man, then the animals, then woman. Also, where does the creator of the universe come from anyway? If we decide this to be unanswerable, why not save a step and decide that the origin of the universe is also an unanswerable question? Or, if we say that God has always existed, why not save a step and conclude that the universe has always existed? This is Carl Sagan from Cosmos. It's entirely possible that the universe is all there ever was, all there is, and all there ever will be. Scripture is poor evidence as it just assumes what it needs to prove, and it appeals to the authority of itself. We call this reasoning in a circle, and it fails to justify credibility. For instance, Scripture says, all Scripture is inspired by God. So the reasoning goes something like this. Why should I believe the Bible is the Word of God? Because the Bible says so. Well, why should I believe the Bible at all? Because the Bible is the infallible, inspired Word of God. The Bible's true. Okay, but wait. How do I know that the Bible is the Word of God? Because the Bible tells us it never stops. You're going round and around. You have no proper grounding for your subsequent beliefs. It would be just as bad if I said we should believe Newton's theory of gravity because the physics book says so. The physics book contains proofs, the observations, the evidence, the logical arguments that Newton produced. That's the justification. In this case, the justification here never has a foundation. No man ever believes that the Bible means what it says. He is always convinced that it says what he means. George Bernard Shaw. Do cosmic and organic evolution explain as well or better than ancient models of the universe and life on Earth? Is modern science enough to explain the complexity of nature? There is grandeur in this view of life, with its several powers, having been originally breathed into a few forms or into one, and that whilst this planet has gone on cycling, according to the fixed law of gravity, from so simple a beginning, endless forms, most beautiful and most wonderful, have been and are being evolved. This is Charles Darwin from the first edition of his Origin of Species in 1859. I should note here that Darwin was a religious skeptic, and in order to appease angry priests and ministers and to tame religious furor, Darwin included the phrase "by the Creator" in the second edition of 1860 and in all subsequent versions of his book. So what exactly did Darwin observe? He saw from his travels and from the findings of others in fossils and in the comparative anatomy of living creatures variations in form and function which especially suited them to their environmental situations. And he found that they had those that were well suited in directions favored by the environment left more offspring. That is, those better suited have more descendants than those less well adapted creatures. Well, why? Evolution happens. Okay, but how? Here are examples of what I take to be superior creatures. They've been around for millions of years, at least 50 to 200 times longer than humans. These are tremendous success stories. Rats, they've been around 50 plus million years. Crocodiles, 80 plus million years, and still wandering Florida golf courses. Cockroaches, 150 million years. So before you stomp on those creatures in your kitchen, you got to realize you're looking at a superior organism. Sharks, 200 plus million years. Coelacanths, this is a bony fish. They've been around for 400 plus million years. They've been around from even way before the dinosaurs. Okay, but doesn't evolutionary theory, without presuming God as the designer, defy common sense? I mean, evolutionary theory finds that whales descend from land-dwelling hoofed mammals. Now, when explaining, you want to avoid the only game in town fallacy. This happens when we infer mistakenly that one explanation must be correct in the absence of better alternatives. And up until Darwin, the dominant best explanation was that God made the world and all of the complex creatures and their adaptations. But let me look at some simpler examples to begin. Suppose someone says, my house is haunted since I hear strange noises at night, but see no evidence of rats. So here the person is considering a couple of hypotheses. There could be rats. I hear these noises. Rats could explain the noises, but so too could my house being haunted. Now, since I don't see rats, I can rule out that hypothesis, so I conclude that the house must be haunted. You should be able to see this is a weak argument, because just because you can't see rats doesn't mean they're there. By the way, there are other explanations of the strange noises besides rats. It might not be rats. It might not be a haunting. It might be a house settling. It might be some neighbors playing hoaxes on you. Another example, the emergency room patient did not have a heart attack since the EKG test is normal. Well, you could do an EKG test, and maybe the person had a mild heart attack, and now there is no longer, they've been sitting in the waiting room for a few hours, there is no longer any evidence of them having a heart attack presently, and yet they actually did have a heart attack. By the way, the EKG machine might be malfunctioning, the tech using it might be making a mistake, etc. Another example, many people report seeing UFOs, unidentified flying objects. So they must be extraterrestrial in origin. But hold on a minute. The idea that unidentified flying objects are only most likely of extraterrestrial origin, that is, aliens from other planets visiting us, is hasty. It's the only game in town because, we want to see aliens visiting Earth. But look, the unidentified flying objects, they're unidentified. That is, whoever is looking at them, maybe scientists even are looking at them, they don't know what they are. They could still be things, normal things. They could be things in the military. The military has a whole bunch of secret aircraft in their arsenals. It could be in other countries or our own meteorological equipment, etc. And finally, this is the theory I'm talking about now as being very powerful explanatorily, and yet not testable. An all-powerful, all-knowing, all-good supernatural creator made the world. Since that is the only way I can account for its amazing complexity and diversity. Sometimes this sort of argument is called the argument from personal incredulity, which means I can't believe all this amazing complexity. I can't believe this design in nature was not the product of an intelligent design. There's no way these things could happen without God, or some God or other being involved. Now that is the position of Plantinga. Again, rival scientific theories have much explanatory power. So I'm going to say both evolutionary theory and intelligent design theory have a lot of explanatory power. Now the issue is here we've got two competing theories. Both make accurate predictions. Both seem plausible, seem true even. And yet we have to find a way to choose one over the other. Again, if we were to say that evolutionary theory and intelligent design theory were compatible, if we were to collapse those into one, which is kind of the status quo position, the position most people try to maintain, although I think it's confused, it's really an intelligent design theory. If you've got in there God must have been involved, even though God used evolution, then that's an intelligent design theory. And the issue is, evolutionary theory neither presumes nor implies any God or supernatural forces, anything beyond the material, the natural world at all. Again, for contrast, consider what each theory says. Intelligent design theory says that this amazing complexity cannot be explained solely on the basis of chemical or biological evolution, but evolutionary theory says it's possible. So, one theory says it's not possible. ID theory says it's not possible to get this amazing design in nature without a guiding intelligence. And the other theory says not necessarily. It is possible. So Plantinga thinks ID has more explanatory theory than ET alone, since only God, as the intelligent, super-powerful creator-designer, explains design adequately. Dennett thinks otherwise. ID has less explanatory power because ID features untestable assumptions about a design or deity. And ID poorly explains design flaws. We will talk about design flaws in eyes, even if we grant the presumption of God. The difference then between intelligent design and non-ID theories reduces to rival answers to one key question. How do we best explain apparent design, complexity, and diversity in nature? ID theories postulate an intelligent designer because such theories presume this, that no mindless process could produce it. Contrast that with non-ID theories that do not postulate any intelligent designers because on these theories, it's possible that some mindless process could produce it. One says no mindless process could produce amazing complexity, and the other says some mindless process could produce it. Those are contradictory views. Only one can be true. They both can't be false, and they both can't be true. When one's true, the other's got to be false. So it is, in this case, either an ID theory of some sort. You can load in natural selection, evolution if you like, or a theory which uses physics, chemistry, biology to explain and know supernatural forces. It comes to this. How do we best explain the amazing diversity and complexity of the natural world? Answers to this question divide people. What follows next on the 24 or so slides is a brief and adequate introduction to evolutionary theory, some of which you should be familiar with from using the UC Berkeley tutorial on evolution and watching the 4 videos in this module. This information is for background understanding only. I am not testing you on the scientific content, which is beyond the scope of this course. The point here is to get you familiar with actual contemporary evolutionary theory, which is widely misunderstood and misrepresented. Shaped by random chance and non-random environmental circumstances, here are some of the amazing organisms and their traits that enable them to survive and reproduce successfully. These are what we want to explain. Here is a basilisk. It has flaps between its toes that produce a larger surface area, allowing hunting sprints across the surface of water at 4.8 feet per second. It runs so fast, it walks on water, so it's also known as the Jesus lizard. The giraffe. It has incisors and molars only. It has these extended cervical vertebrae that permit reaching high branches and neck fighting. It has these defensive horns. If you look at the bones in the neck of the giraffe, you see 7. And yet they have these really long necks. We also have the 7 bones. All mammals have the 7 bones. Here is a hippopotamus. It's a semi-aquatic herbivore. It can't swim, but its massive frame permits sinking, walking, running along the bottom of a river. It has canines, and these are used in foraging and aggressive displays. For comparison, there's a mouse there on the left. Here is a gibbon. It has grasping hands and long arms, which provides superior arboreal locomotion, swinging through trees. A falcon. It has sharp talons. It can skewer moving prey, thin, tapered wings that enable rapid directional change and high-speed hunting dives, exceeding 200 miles per hour. Wolves, dogs. They have these unique carnassial teeth, which can crack bone and shear flesh. Carnassials are why all of these animals are actually called carnivores. They're not carnivores because of their diet. These pointy canines hook prey, and they also are used to threaten rivals. Carnassials are those scissor teeth you can see there in the dog's mouth. Notice they don't have any molars. And a human. Humans have hands with opposable thumbs. They can use and make tools. Long legs enable bipedal sprints and long-distance running. It's what we're good at. Some people more than others. We have big brains capable of cognition, thinking, reasoning, forming complex social groups. We are capable of language and culture. We are the dominant species in less than 2 million years on the planet. Let's focus on that human brain. It's a 3-pound mass of jelly-like fats and tissues, yet it's one of the most complex of all known living structures. Up to 1 trillion nerve cells work together and coordinate the physical actions and mental processes that set humans apart from other species. These are the amazing adaptations and complexities in nature we want to explain. If I may, I'll try to boil evolutionary theory down to 5 claims. Genes mutate randomly. Natural variations of form and function result. Some mutations have no effect. Some are advantageous, and some are disadvantageous. There is this widespread mistaken view that mutations are usually bad. Not really. All they need to persist into the next generation and produce perhaps a variation which is beneficial to the bearer of the mutation, all they need to be is not disadvantageous. They could be neutral. They could be advantageous or neutral. 2, organisms get selected non-randomly. What does this mean? It's the environment that decides who lives, who dies. Where you live, whether you reproduce or you die. 3rd, it's populations that evolve. New species emerge. They endure or they go extinct. There's nothing special about any particular species. Number 4, evolution occurs whenever allele frequencies in populations vary from one generation to the next. And that is the generic definition of evolution. Allele frequencies. An allele is a variation of a gene. You could have the gene which codes for height in peas you can either have the tall variation or the short variation. You can have the brown eyes or the blue eyes, or you can have the attached earlobes or the not attached earlobes. Those are alleles of the same gene, variations, alternative forms of a gene. 5, evolution is not need-based or purpose-driven. See, that understanding comes from the ID version of evolution, which features God with a plan who gives creatures what they need to survive. On evolutionary theory, the outcomes of an evolutionary process, natural selection, genetic drift, random mutation, migration, horizontal gene transfer, this is always going to be either advantageous or disadvantageous or neutral in effect. For more and great examples, really watch that Great Transformations video. I have a link to it for you on campus servers in Module 7. This gives several evolutionary explanations of apparent designs and trends in diverse species. Amazing complexity. Here I'm going to focus on eyes. Raptors, predatory birds, have large eyes with acute vision 8 times sharper than human eyes. Most birds can perceive, bees as well, most birds and bees can perceive ultraviolet in addition to color, and they resolve rapid movements in distant objects 2 to 8 times better than other vertebrates. So they clearly can see better than we do. How eyes could evolve is a really interesting question. I have a short excerpt from a video of biologists talking about how possibly eyes have evolved in the natural world in several lineages, at least 4 dozen separate times. Have a look at that. That's in Canvas. But let's focus on the eye. It's great. We have color vision and depth perception. But the thing is, it's not perfect. Now, we don't expect perfection, although we would expect eyes to be better than they are upon closer examination. And 2 of the biggest issues are that our eyes, vertebrate eyes, are prone to retinal tears, where the layers of the eyes, with age or trauma, can become detached and can make us blind. There is also the problem of nearsightedness and farsightedness. Most of us in our lifetime will be familiar, if we're lucky and we live long, with both. Almost half of humans are nearsighted naturally, at least at some point in their life. This can be corrected now, and of course, as we age, presbyopia, farsightedness occurs. So we have retinal tears, we're nearsighted, we're farsighted, we've got blind spots. These eyes are not the best eyes in the animal kingdom, by the way. Octopus, squids, crabs, birds have better eyes. So there are these serious design flaws in human eyes. I'll mention the 5 from the video. The neural connection of the mammalian eye via the optic nerve to the brain occurs in the front of the photoreceptor cells, the retina, which blocks and scatters light before it reaches them, and it blurs vision. It would be better if that connections were behind the retina. A good engineer would have thought of that. Further, a network of vessels which supply the nerve cells with blood sits directly in front of the light-sensitive layer. This also obscures vision. Squids and octopods don't have this problem. Worse still, the optic nerve connects to the brain through a hole in the retina, causing a blind spot, a region where thousands of impulse-carrying cells have pushed the sensory cells aside. Why not put the sensory wiring behind rather than in front of the photoreceptors? Blind spots obscure the visual field. The light-sensitive inner retinal layer is not well connected to the outer layer, the sclera. Thus, we mammals are prone to retinal tears as we age or experience trauma. And finally, most eyes in humans are nearsighted, and we all become farsighted eventually. So there's some of the problems. These are what we refer to collectively as design flaws, where a smarter committee of designers or designer would have perhaps come up with solutions to these. There are solutions in the natural world. Again, contrary to widespread misunderstanding, the effects of each mechanism of evolution may be beneficial, neutral, or detrimental to reproductive success. Evolution is not random, but some of its mechanisms are. Evolution is not purposeful, though some organisms are. Evolution is not goal-directed, but some organisms have goals. Evolution is not need-based. It's not progressive. It doesn't move towards perfection. It only retains those forms of traits in organisms that enable it to survive and reproduce. And as soon as the environment changes, climate change, for instance, climate becomes too warm or too cold, that's going to have a profound effect on organisms that depend on a particular temperature regime. And finally, evolution does not operate for the good of any organism or species. This is a misunderstanding incorporated into the general understanding of evolutionary theory from the confused philosopher Herbert Spencer in the 19th century. Modern biological theory neither asserts nor implies that the process of evolution has any of these popularly ascribed properties. Nevertheless, any biological complexity, order, morality, consciousness found in nature is contingent upon outcomes of evolutionary processes. So, organisms are not perfectly adapted, and in many cases not that well adapted to all or even their own environments. For instance, humans are remnants of an extinct genus of primates that migrated into Asia, not the pinnacle of evolutionary progress. Intelligent design arguments derive an intelligent designer, creator, from the amazing order, complexity, diversity observed in nature. For example, the cosmos, laws of nature, life, DNA, eyes, brains, species, language, morality, beauty. Simply put, design in nature needs explaining, but theists and non-theists disagree. ID people think God did it, God necessarily was involved. Non-ID people, naturalists, for instance, think nature did it, nature alone could have done it, no God is necessary. This is what they're trying to explain the human eye. Can nature alone, unguided by God, explain this? ID theory says no. Non-ID theories, non-theistic theories, contemporary evolutionary theory says yes. ID theory basically thinks the following: whatever is irreducibly complex or exceedingly improbable cannot emerge randomly from simpler components. Both theories are plausible, but which is better? Plantinga. Christianity is compatible with evolutionary theory because Christians believe that God created the living world, and it is entirely possible that God did so by using a process of evolution. And Dennett agrees, possibly, yes. But there is a better, alternate, testable explanation that explains design flaws, as well as those adaptations. So let's assume that both ID and ET are empirically adequate. That is, both account for data. Which of the following two rival theories explains amazing complexity in nature best? That's our question. Which theory is more testable? Which has more explanatory power? ID theory presumes God did it. ET presumes that a natural process could do it. Intelligent design theory has the following argument: that the origin, development, and extreme complexity of life on Earth can't be explained solely on the basis of chemical or biological evolution, and instead appears to be guided or created by a supreme intelligence. It's an argument, but it refers to an explanation. It's really an argument for accepting an explanation. What you need to do with such complex rationales when it isn't obvious that what is asserted is either an explanation or an argument. Recall that an explanation tells you why something is the case, whereas an argument establishes that it is the case. What you need to do is separate them. Go ahead and reconstruct both rationales. Each starts from the same fact. We want to explain design in nature. but one rationale explains it and the other justifies accepting one explanation over the other. Now, what's the Judgment Day video for the intelligent design explanation of apparent design in diverse species and how it was presented in a court of law? ID explains this phenomenon. Life on Earth is extremely complex. Here's its explanation. If God is a super powerful, supreme intelligence and God is willing and able to create extreme complexity, then God creates extreme complexity. Life on Earth was created by a supreme intelligence, a super powerful deity. Therefore, life on Earth is extremely complex. So we've explained the complexity by reference to a supreme intelligence, super powerful being, namely God. Now, here's an argument for accepting that explanation, the ID explanation. Life on Earth is extremely complex. True. If chemical or biological evolution cannot explain anything as complex as X alone, then X is best explained by a supreme intelligence. Therefore, life on Earth is best explained by supreme intelligence. So you'll notice ID theory is really presuming what it needs to prove, that you can't explain amazing complexity without reference to some God or other. And that's the issue. Plantinga says yes, ID has more explanatory power, and Dennett says no. How could eyes possibly evolve, though, without an intelligent designer? Watch the How Eyes Evolve video to see how complex organs, such as eyes, can evolve via undirected, non-purposeful, natural selection across diverse species. That's the URL, just in case what I give you in Canvas does not link directly to campus servers. Here are relevant details about contemporary evolutionary theory. Darwin observed that creatures with traits especially suited to their environmental situation have more descendants than do less well-adapted creatures. What explains this, if not an intelligent creator? Up until Darwin, the best explanation available was the intelligent creator hypothesis, the God hypothesis. Darwin's naturalistic explanation of apparent design found in nature can be framed as an argument. Organisms vary, and these random but small variations are inherited, at least in part, by their offspring, which resemble their parents in these characteristics. Organisms produce more offspring than can possibly survive, since life-sustaining resources are limited. In this struggle for existence, many organisms perish, but some endure and reproduce. Survivors are typically better suited to local environments than non-survivors. When offspring vary in ways that give them an advantage in their environment, then they will survive and reproduce more successfully, on average, not always, than offspring that are less well suited. Therefore, under these circumstances, favorable variations tend to accumulate in populations. Call this non-random process of differential survival and reproduction based on contingent environmental circumstances natural selection. So favorable variations are those traits that enhance fitness, or the probability that an organism will survive and reproduce in a given environment. Unfavorable variations are the traits that diminish fitness and often lead to the demise of their bearers. Neutral variations are traits that neither diminish nor enhance fitness. When favorable variations accumulate in populations, most constituent organisms appear well suited or designed to fit their environment. If variations useful to any organism ever occur, such individuals will have the best chance of being preserved in the struggle for life. The prevalence of fitness-enhancing traits in populations makes organisms appear designed for their environment. Thus, organisms and their complex traits will appear designed to fit their local environments and modes of life. We observe adaptations, heritable variations of form and function, traits that increase the fitness of organisms and populations. This result, namely apparent design in nature, requires no supernatural intervention, but also does not preclude it. It doesn't rule it out. For instance, common ancestry explains the similarities of arms, paws, flippers, and wings. But natural selection explains their diverse but less than perfect functions. Here's the problem. Now you have to choose between two major theories about the origin and complexity of life. Intelligent design, God did it theism, or evolution. No gods necessary, it's possible without supernatural forces, naturalism, where an agent is going to be a divine creator or natural selection and other mechanisms. So we can also say that natural selection is an agent, although it's not like a person with intentions or plans. Okay, so what we want to explain is this sort of diversity of form and function we find in nature. Darwin and subsequent researchers came to believe that the common structures of the pentadactyl limb found in various animals, even though it had different functions, were derived from the same anatomy, the same common ancestry. By the way, there are other mechanisms of evolution: gene flow, genetic drift, mutation, recombination, in addition to natural or artificial selection. Here's what those things are. Gene flow is when alleles move from one population to another. This can happen when plants cross-pollinate. Genetic drift. This is a random force. It's when frequencies drift randomly across generations, where the frequencies, under no selection whatsoever, randomly fluctuate. Mutations are ways nucleotide sequences which comprise chromosomes rearrange and create new variations in a gene pool during meiosis and DNA replication. A single mutation in the gene, for instance, that makes hemoglobin causes sickling of red blood cells. The resulting phenotype is good or bad depending upon your environment. Recombination occurs when chromosomes swap pieces during gametogenesis, the formation of sex cells. Green and white on this image are homologous chromosomes, that is, chromosomes that come one from each parent. Natural selection. This is where organisms with favorable traits are more likely to survive and reproduce. So there are multiple mechanisms here at work. Artificial selection is going to be the intentional, selective breeding, cultivation, and domestication by humans for certain traits or combinations of traits in plants and animals. For example, 10 of the most common vegetables eaten by people are from a single species of mustard, Brassica oleracea. So broccoli, cauliflower, cabbage, Brussels sprouts, kale, it's all the same species. And dogs. Dogs range in size from Chihuahuas to Great Danes. 5 conditions maintain the appearance of genetic equilibrium, Hardy-Weinberg equilibrium, from generation to generation. Again, in the absence of these forces, allele frequencies don't change. But that's an ideal state. These forces are always at work. Random mating. Random mating occurs when members of a population have an equal opportunity to produce offspring. Now, for instance, most creatures we're aware of, mating is not random. People are very selective with respect to whom they interbreed with. So too are animals. No genetic drift. The larger the population, the less drift in allele frequency. Without mutations, we see less change in the frequencies of alleles in populations from one generation to the next. Again, most mutations are random and harmful, perhaps, but sometimes a mutation is beneficial and better suits an organism to its environment. No natural selection. All genotypes in the population must have equal probabilities of survival and reproduction, but this is rarely the case. Organisms are vulnerable to a variety of environmental factors out of their control, ranging from how many predators there are, how hot, how cold it is, access to resources, food resources, and mates, etc. If any of these 5 mechanisms is occurring, then allele frequencies don't remain in equilibrium and evolution is occurring. So all it takes for evolution to occur is one of these 5 factors. One of these 5 forces causes this change in gene frequencies from one generation to the other. Again, reminding you here that there are several widespread misunderstandings. I've mentioned these. It's a mistake to say that the effects of each mechanism of evolution must be beneficial. They can be neutral. They're not necessarily usually detrimental. Often they have no effect on reproductive success. Evolution is not random. I mentioned how the environment shapes us. The environment is largely out of our control. Some of its mechanisms are random. Evolution is not purposeful, though some organisms are. Evolution is not goal-directed, but some organisms have goals. Or evolution is not need-based, etc. Let's return to the adaptations that are especially troubling for people trying to decide between ID theory and evolutionary theory. Darwin himself called eyes organs of extreme perfection. If it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. But I can find out no such case. No doubt, many organs exist of which we do not know the transitional grades, more especially if we look to much isolated species, around which, according to the theory, there has been much extinction. Again, the difference between ID theory and non-ID theories comes down to this one question: how do you best explain apparent design, complexity, and diversity in nature? On the one side, ID theory says no mindless process could produce it. On the other side, non-ID theories say that some mindless process could. It comes to this: when deciding between only God could do it, the God hypothesis, and nature alone could do it, don't overlook other relevant data. The human eye is amazing, but other eyes are better. Bird vision, for instance, is far superior. Serious eye flaws, where we would expect none if a superintelligent designer made eyes, count against ID. And for Darwin's theory, because evolution predicts that we observe imperfections. An intelligent designer would produce a human eye with superior, or at least optimal visual acuity. But this is not what we have. If God were an engineer, we would have expected a better job. So this is the big issue. Is the God hypothesis or any version of ID disconfirmable? If so, what observations could count against an ID hypothesis? For instance, we might expect that serious design flaws in the design, the production of any intelligent designer would count against the intelligence of the designer, the necessity of the designer, when the alternative theory that explains the amazing complexity plus its imperfections, its otherwise flawed designs, if you were planning them in advance. I mean, if anything, we count as disconfirmation of the intelligent designer hypothesis. We think that would be it. If nothing can count against the God hypothesis, if nothing can count against ID, how can we call it scientific? It's got explanatory power, but when we pit the theories against one another, the traditional theory has weaknesses. Now here's how worldviews are incompatible. This is Plantinga. Like any Christian, and indeed any theist, I believe that the world has been created by God and hence intelligently designed. The hallmark of intelligent design, however, is the claim that this can be shown scientifically. I'm dubious about that. As far as I can see, God certainly could have used Darwinian processes to create the living world and direct it as he wanted to go. Hence, evolution as such does not imply that there is no direction in the history of life. What does have that implication is not evolutionary theory itself, but unguided evolution. The idea that neither God nor any other person has taken a hand in guiding, directing, or orchestrating the course of evolution. But the scientific theory of evolution, sensibly enough, says nothing one way or the other about divine guidance. It doesn't say that evolution is divinely guided. It also doesn't say that it isn't. Like almost any theist, I reject unguided evolution. But the contemporary scientific theory of evolution, just as such, apart from philosophical or theological add-ons, doesn't say that evolution is unguided. Like science in general, it makes no pronouncements on the existence or activity of God. So to summarize Plantinga, contemporary evolutionary theory is compatible with theistic belief. The basic theses are acceptable to theistic religious people. Only naturalism, according to Plantinga, says God did not make the world. But evolutionary theory does not say this. Plantinga rejects unguided evolution. Earth is ancient. Descent with modification happens. Organic diversity is due to small changes in gene frequencies in populations. All life shares a common ancestry. Natural selection is the principal mechanism of evolution. And none of this implies that God does not exist or that the process was not guided by God. So, how are religion and science incompatible? Plantinga wonders. Well, in the first place, natural diversity and complexity is created by God on the ID theory. Each creature is especially created according to God's plan. And on the evolutionary theory, natural diversity and complexity is produced by nature, with or without God. On ID theory, humans were especially created by God. On evolution theory, humans evolved from apes. Here's the tree showing the divergence of human and ape species. All of these are apes. Approximate dates of divergencies are given for, from left to right, the orangutan, the gorilla, the human, the bonobo, pygmy chimpanzee, and the chimpanzee. So we ask again, how are these two theories incompatible? I think it's becoming clearer that on ID theory, there's got to be guidance. There has to be an intelligent designer. And on non-ID theories, an intelligent designer is not necessary. A designer, natural selection, is sufficient to explain what we see. I mean, here's what you have to ask yourself. Can a religious and scientific person really say, and mean it when they say, you don't really need God to explain nature's complexity and diversity? We see Plantinga doing this. He's saying, we do need God to explain it. Can a religious and scientific person say it's sometimes acceptable to just believe and teach something to children on the basis of sincere faith alone? And recall, in science, we're supposed to get evidence before we accept a claim. Doubt first, defeat doubt by overwhelming evidence and argument. Can a religious person who also claims to be scientific say religion explains some events which science cannot? Well, if so, how does it do it? How does saying God did anything explain it? God would be the cause. But how did God do it? Why did God do it? And again, where did God come from? And so long as we're on the subject, which God are we talking about? Unlike religious faith, the scientific process requires evidence-based observations and tests. And this schematic diagrams more or less what I've been presenting to you in this course. There are then, as I see it, at least three major philosophical incompatibilities between religious and scientific worldviews. Each disagrees about the necessity of a divine creator. Either an intelligent creator must exist given evidence, or it is not the case that one must exist given the same evidence. 2. Each disagrees about how best to explain phenomena. For example, amazing diversity and complexity in nature. For example, ID says you can't adequately explain complex phenomena without God, but evolutionary theory says you can. 3. Each cultivates incompatible attitudes about claims. Religion values faith, believe regardless of evidence. Science values doubt or skepticism, believe only on the basis of compelling evidence. How is a faith-based method compatible with a doubt-based method? Okay, it's time to take a closer look at what Plantinga and Dennett are doing in their debate. But first I have to contrast naturalism and evolution. Plantinga says naturalism and evolution together, combined, is false. Where naturalism is the idea that there is no such person as God or anything like God, we might think of it as high-octane atheism, or perhaps atheism plus. And evolution is this idea, the belief that humans have evolved in conformity with current evolutionary theory. Dennett rejects naturalism. He thinks it's false. And so he's going to reject the combination of the two, naturalism and evolution, even if he accepts evolution. Dennett and others find Plantinga's account to be simplistic on contemporary evolutionary theory. So here's a summary. Dennett notes that alternate, non-theistic accounts of the cosmos are also possible. Plantinga is right. Contemporary evolutionary theory is compatible with some theistic beliefs, but it is also compatible with non-theistic or non-mainstream theistic beliefs. Extraterrestrial origins and alternate mythological beings as designers of organic complexity are compatible with theism. So why accept one origin story over another? Theism doesn't explain better than naturalism, especially since it just presumes what one cannot demonstrate, namely that a specific sort of designer, deity, or God needs to exist at all. Yes, contemporary evolutionary theory does not demonstrate that there are no gods, just like it cannot show that other alternate origin stories are impossible. But conceding this purchases compatibility at the expense of demoting Christianity. Other gods or aliens could also be responsible. Such stories are also possible. Contemporary evolutionary theory demonstrates that natural origins are possible too. So, no specific origin story is necessary. Comic book accounts of origins are no more silly than biblical accounts. Both are plausible. Both suffer from a lack of evidence. Testable origin stories are better than non-testable ones. Second point Dennett makes, the alleged and unacceptable randomness, unguidedness of natural processes is a red herring. It's a distraction. It's irrelevant to whether we accept theism or naturalism. In fact, randomness is compatible with contemporary evolutionary theory, but not theistic accounts of the origins of natural complexity, diversity, and adaptations. Theism must demonstrate that one particular, super-powerful, non-physical, supremely intelligent designer of the cosmos is necessary. And it must show that no other explanation is plausible. Contemporary evolutionary theory does not prove evolution is unguided, yes, but if diversity and complexity and adaptations can evolve without being guided by any gods, then it does show that a guiding hand or intelligent designer is not necessary. As soon as one grants contemporary evolutionary theory is possible, you displace the necessity of any god in the origin of organic complexity. Point 3. Plantinga is correct when he says naturalism and contemporary evolutionary theory together imply the denial of design by God. But contemporary evolutionary theory by itself does not have that implication. What he can't accept is that if contemporary evolutionary theory alone is true, that it shows supernaturals are not necessary to explain design. But then, and lots of scientists use evolutionary theory to explain without gods or any other supernaturals. I just keep hearing Plantinga saying, in effect, that he can't imagine evolution happening without God's intervention. Yet this is not a good argument that God is necessary, especially when other gods may instead be involved. There is room for God in contemporary evolutionary theory and physics and chemistry, but then there is room for lots of other gods as well. Naturalism need not be presumed or denied to see that the burden of proof for a designer, God, rests with the theist who says an intelligent designer is necessary. Scientists who think we can explain apparent design by natural processes don't see why no designer is impossible, unless you can show why a God is necessary, or that it is not possible to explain without one. Science works without supernaturals. It doesn't matter what gods you want to include. None seem required. Naturalism is not a commitment to the belief that no gods, supernaturals, or magic exists. It's just the idea that we can describe and explain what happens in nature without them, unless you can prove otherwise. Recall from earlier lectures, I discussed metaphysical versus methodological naturalism. Metaphysical naturalism is not the same thing as methodological. Okay, metaphysical naturalism says there are probably no supernatural entities, forces, or processes. And this is based on, well, absence of evidence. It isn't necessary that there are any such things. We can imagine that such things do not exist. We might be wrong. However, methodological naturalism says presume no supernatural entities when explaining. So the method of naturalism here, methodological naturalism, is the idea of explaining without reference to extraneous supernatural entities. So it's the difference between the view that there is probably no magic and the view that let's explain what we observe without magic. Could there be magic? Sure. Must there be? Not necessarily. No scientific theory requires it, and none rules it out. Dennett's artist Tom killed critic Fred story shows how lots of other stories are consistent with intelligent agency, like theism plus contemporary evolutionary theory. But unless such stories satisfy the evidentiary burden of proof, as do those without intelligent agency, we, the courts, and science, won't take them as serious contenders. Mere compatibility, plausibility, are never enough. Lots of other stories are compatible: Egyptian, Native American, Greek, Roman, with intelligent design. You have to justify a theory based on observables, and then it must explain better than its rivals. Plantinga thinks it's more likely that we have these superior cognitive abilities given God than if there is no God. But the evidence is lacking. On what objective basis does he justify this assumption? He seems, again, to base it on his and others' shared incredulity. They just can't believe otherwise. In fact, many argue, given serious design flaws in organisms, the thesis that there is no designer, or a not-so-great designer, is stronger. Besides, Plantinga's line of reasoning cannot rule out alternative possibilities: multiple gods, lesser gods, aliens, many-world scenarios, natural processes, etc. In short, other origin stories are logically conceivable. To prefer one over any other on the basis of what one can or cannot imagine is narrow-minded, short-sighted. We do not limit what is possible to what is conceivable. We proportion belief to quality of evidence, not mere possibility or lack of contradictions. Zoroastrianism is one of the oldest religions in the world. In its creation story, there are two opposing forces, Ahura Mazda and Angra Mainyu. Why not their creation story? To prefer one origin story over any other based on hearsay or on the basis of what we can or cannot imagine is prone to bias and error, as we've seen. We believe what we want to believe, or what our elders and leaders tell us, because we are raised to trust their authority. But what other origin stories are possible? Just look at the list of creation myths entry in Wikipedia. The only limits are in what people can imagine, if no evidence beyond ancient scribblings is available, and if no scientific evidence can count against any of these stories, then choosing to accept one story and reject the rest based on tradition or culture is arbitrary, self-serving. Many religions have a single creation story. Some, such as Hinduism, have many, or none. For Hindus, there is no single creation, but periodic cycles of creation. The universe we live in is one of innumerable universes co-created, maintained, destroyed by Brahma, Shiva, and Vishnu. Perhaps ours is not the first world or the best world. Speculation runs rampant when we swing free of the need for testable evidence. Hindus believe there have been and will be many more worlds and universes than there are drops of water in the holy river Ganges. Why not? We've reached the end of the course. That's all I have to say about that. Some final parting advice. Never trust what you find yourself wanting to be true. That's a red flag. Only trust those sources who cite original research featuring claims subject to disproof. All right, this is the end of the last slideshow for Philosophy 125 with Professor Scott Merlino. I'm glad I was able to share this material with you. Goodbye and good luck.